Hello students, this is your teacher Yasir, and today we are discussing about the topic Surds. What are Surds? Before going deep into Surds topic, we must know two things, which is rational and irrational numbers. That's the previous topic, but you should know rational numbers and irrational numbers to get the basic idea of a Surd. Okay? Rational numbers can be expressed as fraction p over q. P over q, this p and this q, both must be integers, okay? And q must not be equal to 0. They both must be integers and the value of q must not be equal to 0, okay? It should be any other integer, okay? Wherein p and q are integers and q is not 0. Irrational numbers. What are irrational numbers? Irrational numbers are those numbers which cannot be expressed as a fraction of two integers. Okay. A key difference is that rational numbers have decimal expansions that either terminate or repeat. Rational numbers have decimal expansions like 7.345 and so on. There is no repeating pattern in it. Okay. If there is a repeating pattern, then you can convert that type of decimal into p over q, okay, or a over b. So a key difference is that rational numbers have decimal expansions that either terminate or repeat. What do you mean by terminate? Terminate means like 0.716. Okay. Now that is easily terminated, right? Means there is no other point after this. There is no number written after this. It's terminated, right? Terminated means that you can convert it into a fraction like this. 716 divided by 1000 gives you 0.716, and since these two are integers, you can say this is a rational number. Now, for example, a recurring decimal 0.3 dot, this can also be converted to a rational number 1 over 3, right? Any negative number can also be written as negative 4 over 1. So this is also a rational number. So what we have learned, a key difference is that rational numbers have decimal expansions that either terminate or repeat, while irrational numbers have non-terminating. Like in this example I have given you, that 7.345 and going on. Like value of pi. Now pi is not equal to 22 over 7. Okay, it's approximately equals to 22 over 7, but its value is, actual value is 3.14 something. Okay, and it's going on forever. Okay, scientists is still figuring out that what's the pattern in this number, but there is no pattern. Okay, there is no such pattern they have seen till now. Non-repeating decimal expansion. Okay, non-repeating, just same as this. Okay, so I have given you a basic idea what rational numbers are, what irrational numbers are. To just have a one liner, rational numbers are those which can be expressed in the form p over q or a over b, where b should not be equal to 0. Okay, all other things means like if you can write it as a p over q form, then all those numbers are said to be rational. Okay, all integers are rational. Okay, irrationals are those which having a non-repeating decimal expansion and non-terminating decimals, right? So the question arises, then what is a surd? The question arises, then what is a surd? So surd is the root which produces a irrational number. Okay, it's the root which produces a rational number, or in other words you can say it's a fractional power which produces a rational number. Now what is a fractional power? What do I mean by? Okay, now let's start again. So what thing I have to tell you, that we have understand that this sign, if produces an irrational number, that is a surd. That is a notation to write a square root. What this notation tells you? This notation tells you that the power is half. Okay, this root means a fractional power half. Cube root means a fractional power 1 over 3. Fourth root means a fractional power 1 over 4. Then you may ask, sir, why we haven't written 2 over there? Since it's a notation, okay? Since it's a notation, you write a square root like this, okay? Like 1x always written like x only, okay? We don't write 1x, we just write x. So it's understood that it's 2, okay? So whatever written over there, what it tells you. Now let's see what it is telling you, that what index power basically means, right? So let me delete this bit. Now, what this bit tells you, basically this bit tells you that if I have 2 power 2 and I have a half power, it will become 2 square. And you know, according to the rules of indices, that if you multiply this with this, what happen? It will become 1, right? So 2 power 1. That will be the answer to this question, right? So in another words, we can say that this number tells us that how many same numbers required to make a pair, okay? For example, if I have a square root 2 times by 2 times by 2 times by 3. Now I have this same, two same numbers means I have one pair. And since it's a square root, I will bring one out of the pair, okay? I will bring one out of a pair of 2. This numbers tells you that how much numbers required, how many same numbers required to make a pair, okay? So 2 numbers are required to make a pair. So 2 same numbers are this 2 and this 2. So this 2 will come out and this 2 by 3 stay inside, right? Now for example, if I have a cube root, and the same numbers 2, 2 and 3, this number telling me that I need 3 same numbers to make one out. 3 same numbers to make one out. So this 2 will come out and this 3 stay inside. Now this thing is done, this thing is done, okay. What is 1 over 4 power? 1 over 4 power means the same again. It means that if I have 4 same numbers, I can bring one out, right? So for example, if I have 5, 5, 5, 5, 5, 5. Since I have 4 same numbers, I can bring 1 5 out. Okay, I can bring 1 5 out and the fourth root of 5. So we have done two things. One is that this root means half power. This cube root means 1 over 3 power. This fourth root means 1 over 4 power. And this number tells us that how many numbers are required inside the root to make one out, right? Now, for example, these are square numbers, right? These are square numbers. This 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on. So since they are already a pair, there is already a pair, 2 square, 3 square, right? So for example, if I write 9, root 9, it means I am writing 3 square, 3 by 3. This is a pair, so 3 will come out, okay? Means if I do a root of square numbers, a base of the square number will come out, right? This is the base, right? For example, if I square a root 16, if I take root 16, then 4 will come out. Why? Because the base is going to come out, right? And we already discussed that we can also write 4 by 4, and if there is a pair, one number will come out. That way you also get 4 as an answer. Likewise in cube numbers, if for example this is 1 cube, this is 2 cube, this is 3 cube. If I am taking a cube root of 27, base of that cube number will come out. So base is 3, so 3 will come out. In other words, you can say that cube root of 27, you can write 3 by 3 by 3, and this number telling us that this 1 3 must be come out, right? So that's the basic thing. Now we have to multiply surds, divide surds, factorize surds, and addition and subtraction of surds. I'm only deleting this part because in this part maybe you need a little bit explanation. Multiplying of surds. It's very easy. It's very simple. If you are multiplying two surds, you just directly multiply the numbers inside the two roots, provided both having same power. Means here you see that it's the square root, here you see this is also the square root. It's not happening in, for example, if I have a root and I have a cube root, now I can't write it in one umbrella. Okay, if I have to write it in one umbrella, then this numbers must be same, right? Since both are square roots, I can write 3 and 5 together in multiplication. Okay, this rule only works in multiplication and in division. Okay, if you're dividing two numbers, you can divide directly like this, 21 divided by 7. So you can divide like this, multiply like this. Factorizing surds. What is factorizing surds? In factorization of surds, if you have to write 35, 5 times 7 and 7 times by 1. So you can see that 35 can be written as root 5 times by 7, right? So you can separate them also. For example, you have, let's say, you have 60. Let's say you have 60. 2 times 30, 2 times 15, 5 times 3 and 3 times by 1. So you can write 2, 2, 5 and 3. Here you can see there is a pair of 2 and 5 is alone here and then 3. So 5 and 3 will stay inside, this 2 will come out. Since if there is a square number, a base of that square number will come out. Okay, it's a 2 square, right? So base of that is 2, that will come out. Or you can say if there is a pair, one number will come out of it. Both ways it's correct. It's the same thing. Now let's deal with addition and subtraction. Addition and subtraction. Now what we do in addition and subtraction, we already know if we have like terms, we just add the coefficients of them. For example, if you have 5x plus 3x, you do 8x, right? Means you are adding the coefficients of x, because since they both are like terms. That's the same rule you apply in surds. For example, you have 3 root 5 plus 6 root 5. What it means that you can combine this 3 and this 6 together and it will become 9 root 5. Okay, means you add the coefficients and then you write. Now for example, someone says that I want to put that 3 back again. Are you able to do it? If for example I will say, let's say it's 3 root 5. I want to put that 3 again back. How I will do it? I will do it, I know that if it is coming out, it's a pair that is coming out, right? So I will write 3 and 3 inside the root. Okay, since I know if this is a pair, this will go out, right? So if I have to put back in, I have to place two numbers, right? So like this, 3 times 3 is 9, 9 times 5 is 45. So that's how you can put back in also. Okay, so these are the rules which you have to know for surds. Now this, coming back to our topic, now we are solving, simplifying, adding and subtracting surds. Here you can see this one is very easy. Root 16. 16 is a square number, a base of which is 4. So 4 will be our answer, right? Because a square can cancel the square root. Okay. Or if you have a root and a square, they will also cancel. Okay. So this is just the extra thing. Means what we have understand, that if there is a square number inside the root, base of that will come out. 4 is the base of 16 square, means 4 square is 16. So 4 will come out, right? 28. Since 28 is not a square number, we will find the factors of it. 2 times by 1, 2 times by 4, 2 times by 7. These are the prime numbers. Then we can write 2 into 2 into 7. Pair, you will get 1 out, and all the other things stay inside. That's your answer for this. Root 63. Again, we do the same thing. 63 can be written as 3 times 2 is 6, 3 times 1. 3 times by 7. These are the prime numbers. Pair, 1 will get out. This 7 stay inside. 3 root 7 is your final answer. Now, adding and subtracting the surds is similar like doing uh, what you do in like terms, like 2x plus 3x is what? 5x. What you did, you add the coefficients. Likewise, if you have like surds, then you just add the coefficients of those. Why? What's the reason behind this? The reason is very simple. You already know factorization. So common is root 5, right? Root 5 will come out. This 2 plus 6 will stay inside. 2 plus 6 is 8, and then 8 root 5. Okay, that's your answer. Likewise, 4 minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is 3. 3 root 11 will be your answer. Okay, means this is not necessary that you take the common out and then add it. You just do as you did the normal algebra questions, in which you can directly add or subtract the like terms. Like now 4 root 2 and 8. 8 can be written as this 2 is common, this 2 stay inside. 4 root 2 minus 2 root 2. 4 minus 2 is 2. 2 root 2 will be your final answer. Now let's check this. 28. 28 can be written as 2 times by 14, 2 times by 7, and 7 times by 1. This 2 will come out, and this 7 stay inside. We have 3 root 7. 3 plus 2 is 5 root 7. 270 minus 120, you did this yourself. You did it yourself. Now we are doing multiplying of surds. In multiplication, you have to check that the roots must be same, means their power must be same, their fractional power must be same. In this, it's a square root, and this also a square root. So what you do, you time 5 by 2, which is 10. Okay, 24 divided by 6. Same goes with division. This rule that you can write it in a same root is only applied for multiplication and for division. 24 divided by 6. 6 times by 4 is 24. So root 4, and 4 is a square number, base of which is 2, right? 2 square is 4, right? Since this is in root, so when a square number is in root, it originated from whichever number, that number is your answer. Okay, means the base of that number is your answer. 2 is the base, so 2 is your answer. Next question. As you already know that a square can cancel the root, 11 is your answer. Why? Because earlier we discussed that root is having a fractional power of half. Half multiplied by 2 is 1. Therefore 11 is your answer. 2 times by 5 is 10. 5. Now 15 and 3 we can write it in a same one. 3 times by 5 is 15. Therefore 5 root 5 is your answer. 12 plus 48. 3 times by 4 is 12. Root 48. 48 can be written as 2 times 2, 2 times 4, 2 times 1, 2 times 2, 3, 3. How many pairs? 2 pairs of 2. That will come out. 2 and 2. What is stay inside this? 3 and 3. 3 times by 4. Since 4 is a square number, this 2 will come out. 3, 4, root 3 over 3. 2 plus 4 is 6. 6 root 3 over 3. Now this 6 and this 3 can be divided by 3 times by 1, 3 times by 2 is 6. So 2 root 3 will be your final answer for this one. Now this square and this cancelled out. 2 times by 5 is 10. 10 over 10 is 1. This is simple. This is simple multiplication expansion of brackets. 24 and root 3 root 5, right? Now we multiply this with this and this with this. 6 root 2 minus root 2 times by root 3 is 6. 6 root 2 minus root 6 is your final answer. Question number 9. 3 by 18 and 3 by 2. 18 can be written as 3 is a pair, right? That will come out. Inside 2 is remaining minus root 2. Now it's up to you that whether you first multiply and then simplify, or you simplify first and then multiply this 3 outer 3 with the answer. 3 root 2 minus 1 root 2 will give you 2 root 2. 2 root 2 times by 3 and divided by 2. Now you can cancel this 2 with this 2, or first you multiply and then cancel, whatever suits you. 6 root 2 over 2, then 2 times by 3 is 6. So 3 root 2 will be your final answer for this question. Now we have another ones in which we have a plus sign and a minus sign. A plus sign and a minus sign. We have to check that is the rule of a plus b, difference of two squares, is applicable or not. Okay, in this type of questions we will check that whether a plus b or a minus b is applied or not. A plus b and a minus b applied when the items are same and in between them the signs are changed, like in question number 11 the signs are changed but the items are same, so you can apply this formula. Since in the first case this is not the case, the items are not same, we are not able to apply a plus b and a minus b. We will expand simply. How we expand? We multiply this with this bracket, we multiply the second with the second bracket, right? 3 times by 2 is 6 minus 3 root 2 plus 2 root 3 root 6. Okay, root 3 times by root 2 is root 6, and that's what your answer is. Okay, next question. This is done. Okay, now question number 11, 4 plus root 3 and 4 minus root 3. In this question, we can apply formula of a plus b and a minus b. How we apply a plus b and a minus b formula? This is our a, this is our b, this is a, this is b. So a square will be 4 square minus b square, which is root 3 square. 4 square is 16, and this square will cancel the root. 16 minus 3 is 13, and that's your answer. Okay. Likewise, let's do question number 12. Now it is a minus b whole square. The formula of which is a minus b whole square. The formula is a square minus 2ab plus b square. Now do the formula. Root 72 square minus 2ab. 72, b is 50, root 50, and plus b square. B is root 50 square again. This cancels this. 72 minus 2 root 72 and 250. Now you can simplify this. That's 72 and 50. You can simplify this. So to simplify this, let's write 72, taking the factors of 72. 2 times 3 is 6, 2 times 6 is 12. 2 times 1 is 2, 2 times 8 is 16, 2 times 9, 3 times 3, 3. Pair is this and this. This will come out. 2 times 3 is 6, and 2 will stay inside, right? Likewise, root 50 can be written as 2 times by 5 times by 5. Means 5 can come out. 5 root 2 can be written, right? So I am writing 5 root 2 for root 50. And this 2 stay inside, outside. Plus root 50 again. 5 root 2 is the answer for root 50. Now let's do the calculation, remaining calculation. 72 minus 2 times 6 is 12, and 12 times 5 is 60, and root times 2 times by root 2 is 2. 5 square is 25, and root 2 can be 2. 72 minus 120 plus 50. Now we just have to solve this. You can do it in your calculator. 72 minus 120 plus 50, and that gives you 2. That's your answer. Now the only part remaining in this is doing the surds thing. Okay, surds, rationalizing the surds. Okay, the only part remaining is rationalizing the surds. What is rationalizing the surds? That is that when you are having a denominator involving a root, you multiply it with the conjugate. Okay, if there is a plus minus sign in between, you multiply it with the conjugate. Otherwise you simply multiply with the root. For example, 1 over root 3. Then what you do in this case, you just multiply root 3 top and bottom. Okay, that way root from the denominator is going to be removed, right? Root 3 times by root 3 gives you 3 only. 1 times by root 3 is root 3. So see, from the denominator, it goes in the numerator. Okay, likewise, root 6 times by root 6. So it will become 3 root 6 over 6. Now let's just rationalize few of the denominators with the plus minus sign. So whenever you have a plus minus sign, then what we do? Then we multiply it with the conjugate, 7 plus root 2 times by 7 minus root 2 over 7 minus root 2. This will become 7 minus root 2. Again, it's a plus b and a minus b. Okay, so when you have a plus b and a minus b, you square the first one, square the second one, and in between them there is a minus sign. That's we learned just above. If you haven't, then watch it again and you will understand it. 7 minus root 2, 7 square is 49. This square cancel the 2. So 49 minus 2 is 47. And that's how our full spectrum of search topic is covered. In the next video, we will do uh, exam questions regarding search and some applied variety of search. We are going to observe the exam questions chapter search. Show that questions are very easy because the answers are already given in that. They are saying that can be written in the form a root 6, where a is to be found, right? A is an integer, right? They have given it. So what we have to do, we take this and try to make it this. So we have root 2 times by root 48, then this root 2 times by root 27. As I earlier told you, we just find out the factors of 48 and 27. 3 times 9, 3 times 3, 3 times 1, 2 times 2, 2 times 4, 2 times 12, 2 times 6, 2 times 3, 3 times 1. So this and this is a pair, means out of this 48, this 2 and this 2 comes out and this 3 stay inside. And this root 2 is also there. Plus likewise 27, this 3 will come out, root 2 stay inside, this root 2 is here, and from this 27 what's left? This 3 is left. Now we know that it is 4 and root 6 plus 3 root 6. Root 6 and root 6 is a like term. 4 plus 3 is 7 and 7 root 6 will be our final answer. Now 7 minus root 3, 7 plus root 3 divided by root 92. In this case, what is A? A is our 7, because you can see that in root we have 6. Okay, so in root we have 6 and therefore this is A and A root 6, which means A value is 7. Now 7 minus root 3 plus multiplied by 7 plus root 3 is what? In this type of question, when you have A minus B and A plus B, means two same items and in between them the signs are different, you can always apply the formula. That will be the easier approach to do this question. Okay, if you expand it, you will waste your time. Okay, so 7 square is 49. This will cancel this, 9 minus 3, and root 92 can be solved further. 2 times by 4 is 8, 2 times 6, 2 times 2, 2 times 3, and 23. Okay, So this 2 will come out and this 23 stay inside. Now 49 minus root 3 is 49 minus 3 is 46. 46 over 2 root 23. Since they didn't say rationalize, we are not concerned about this denominator, okay? Now 46 divided by 2 is 23. Now, if you want to rationalize, you just have to multiply root 23 and 23 in the denominator. What you will get from the denominator, this 23 will become only 23, and from the numerator it will become 23 root 23. Okay, and that's how this will cancel this, and root 23 will be your final answer. So what we observed here, that if that is the case, direct answer will be this. Means you just write this denominator upside and that will be your final answer. Okay. Okay, next question. Rationalizing the denominator. Again, the same style of question, just multiply root 12 over root 12. Root 12 is 12 and 5 root 12. That's your answer. They are saying that show that this can be written as this. Okay, very easy. Multiply the conjugate. This is a minus b, a square minus b square. Okay, that's the formula of a square minus b square. This will cancel this. Now in the top we are multiplying this together. 9 minus 2 root 24 times by root 6 minus 3. That gives us 9. 24. 24 can be written as 2 into 12. 2 into 12. And 12 can be written as 4 into 3, which is 2 times by 3. Okay, so that is 24. How we write 24? This is a pair. This will come out and the 6 will stay inside. 2 root 6 will be the answer for root 24. 2 root 6. Okay, multiplied by 9 minus 2 root 6 multiplied by root 6 minus 3. 6 minus 9 is 3 square makes 9. 6 minus 9 is minus 3. Now we just have to simplify this. Okay, I am deleting from here so that I can do the remaining question on this side. This multiplied by this 9 root 6, this multiplied by this 9 times by 3 is 27, then this nine times by root 6, 9 root 6, 9 times by 3 is negative 27. Then this negative 2 root 6 times by root 6 is 2 times by 6, which is 12. Okay, 2 root 6 times by root 6. Root 6 times by root 6 is 6. So 2 times by 6 is 12. Okay, so I'm writing 12 only, negative of 12. And then this 2 root 6 multiplied by 3, 3 times 2 is 6, plus sign, minus and minus makes plus. This minus and this minus makes plus. And 2 times by 3 is 6 plus 6 and root 6. Now 9 plus 6 is 9 plus 6, 15. 15 root 6 minus 27 minus 12. So you do 27 plus 12, which is 39, and negative 39. Okay. Okay, that's the numerator part. That's our numerator part. Now what we do, we divide it with negative 3. Since we are dividing, we can write 15 root 6 minus 39, and this is minus 3 and this is minus 3 also. I deliberately do this style so that I can show you if you stuck with this. Minus and minus makes plus in division also. 39 divided by 3 is 13. Okay, that's what we want, plus 13. Okay, and 3 times by 5 is 15. Plus and a minus sign makes minus. That's what you can see here, minus 5 root 6. That's your answer. You can rewrite also, or you can rewrite 13 minus 5 root 6. Both ways are correct to do this question.